Example 1 here on the sine and cosine rules, we're taking a look at the application of the sine and cosine rules. And like we can see here from our diagram, we have a system of two triangles which are attached at the side of length 5 cm. So we can see they're attached here along this side length of 5 cm. And we're asked for two values here. We're asked for the value of x, representing this side length here, and we're asked for the value of alpha here, this angle here. Now here in this case, it doesn't actually matter which one we start to find first. So whether we look to find x first, or whether we look to find alpha first. However, as we noted previously, you may need to find one of these values first to be able to work out the preceding value. So in this case, if it doesn't matter, what we'll do is we'll start by working out the value of x. Now here, what we know is this top triangle here is actually an isosceles triangle. And we know that because we have these equal side lengths here. So in that case, if this is an isosceles triangle, what that means is these two base angles here must be equal. And we can simply calculate those base angles here by taking 20 degrees from 180 degrees and dividing that by 2. And if we work that out then, that's going to be 180 minus 20, giving us 160. And we divide this by 2 to obtain 80 degrees there. Okay. So these angles here are 80 degrees each. So that's 80 degrees, and this one's 80 degrees. Now what we want to use here now, we're either going to use the sine rule or the cosine rule. And remember, to deduce which one we use in here, we just take a look at our triangle, and because we know at least two individual angles here, we've got 20 degrees, and we've got 80 degrees, and we know one of the side lengths, which is x here, then we can simply apply the sine rule. Now if I label this vertex here, representing this 80 degree, or this angle here of 80 degrees, as this is little x here, we'll call that capital X. And same again here, in this case, I'm going to call this capital Y, so this is little y here. Now in this case, we can simply apply the sine rule. This is going to be little x here over sine of x, this is going to be x over sine of 80. And this is going to be equal now to 5 over sine of y, which is sine of 20 here. Now in this case here, all we simply need to do is solve for x. And in this case, to solve for x, we're just going to multiply the left hand side of this equation and the right hand side by sine of 80 degrees. So therefore, x is going to be equal to sine of 80 degrees times by 5 over sine 20 degrees. And if you evaluate this on your calculator, what you should obtain here to a sensible degree of accuracy here is 14.40 centimeters there. Okay, so that's our value of x there. And now, again, we've got one more value that we need to find, and that's this value here of alpha. So, to find alpha, we're going to be using this triangle at the bottom here. And in this case, as we know all three side lengths, we're going to use cosine rule. So if we denote the cosine rule first, so the cosine rule here is simply a squared is equal to b squared plus c squared minus 2bc cos a there. Okay, and we're simply going to use this formula now to work out this value of alpha. And all we need to do now is label appropriately here the values that we want here using a, b and c. Now as we want the angle here of alpha, what I'm going to do is label this side here now. So let's get rid of that y, let's call this a. That means this will be capital A, then this angle here. Okay, so that's going to be our cos A. And then in that case, it doesn't matter which one of these two you label B and C. I'm going to label this one B here, and this one C. But again, it doesn't matter too much. So all we simply do now is substitute our values in. So A squared is 5 squared, which is equal to B squared being 6 squared, and C squared being 7 squared here. We do minus 2bc. It's going to be minus 2 times b, which is 6, times by c, which is 7, and then we times that by cos of a. But remember, we don't know what this capital A here is. This is just alpha, so we write this as cos alpha there. And in this case here, this is just simply a matter of evaluating as we go across. So we obtain 25 is equal to 36 plus 49 minus 84 cos alpha. Okay, and we're pretty much here now. What we can do then is rearrange this to be in terms of cos alpha. So therefore what we're going to obtain is 84 cos alpha is going to be equal to 36 plus 49 minus the 25. And if you work that out here, that's going to give you 60. So therefore we're very, very close here. Remember, we want the value of alpha. So first we need to divide by the coefficient here, which is 84. So therefore cos alpha is going to be equal to 60 over 84 here. And therefore, if we just want alpha now, all we simply need to do is take cos inverse of the left hand side and the right hand side. And if we take out the left hand side here, so if we just finish this in a different colour at the top, so therefore, if we do it in this box up here, just so we can see it clearly, therefore alpha is going to be equal to cos inverse of 60 over 84. So 60 over 84 here. And once you work that on your calculator, again, just be slightly careful here. Remember, we're going to be working in degrees here. Therefore, alpha is going to be equal to 44.42 degrees there. Okay, so we know alpha here is 44.42 degrees there, which gives us the solution to example 1 on application of the sine and cosine rules.